In this lesson you will learn how to make use of the head tracking. As a first exercise, we will allow the player to shoot objects while aiming with the head so that objects fly off in the direction in which he is currently looking at. Extend the contents of the OVR player controller. We want to identify the direction that the player is looking in. Don't be misled by the game object named forward direction. This is the actual rotation of the player controller. Think of only turning your head in real life. The forward direction then would be the direction your shoulders are facing. Let's extend the contents of the OVR camera rig. The direction that we are looking for is held in the center eye anchor. We can use it for our shooting script later. Select the center eye anchor in the hierarchy. Notice that it mainly consists of a transform. Press the play button to test the scene in the editor. Move your Oculus Rift around and observe the attributes of the center eye anchor's transform change. Aiming and shooting is something that our player controller should be able to do. We can add the skill to the player controller game object by adding a script to it. I will do my best at explaining everything we use for our script. If you are having trouble understanding some of it, I generally advise you to see the official Unity scripting tutorials. I will link you to the parts that we need for this tutorial in the sources. Now select the OVR player controller and press the Add Component button in the inspector. Type Aim and Shoot in the search field and press Enter to create a new C# script. We want to access the transform component of the center eye anchor in our Aim and Shoot script. Type Public Transform Direction in between the class definition and the start method. This will create a variable of the type transform. By setting its access modifier to public, we can assign the appropriate transform component in the editor. Save a script and switch to the editor. Notice that our direction attribute is now listed in the Aim and Shoot script. Currently it shows none and transform in parentheses. This means that currently nothing is connected to our direction attribute just yet and that it expects a transform. We can select the OVR player controller in the hierarchy and simply drag and drop the center eye anchor's game object onto the empty slot in the script. This will connect the center eye anchor's transform component to the direction attribute of our script. Even though we now have access to the direction that we want to shoot in, we still need some game object to shoot. Type public game object bullet in the next line to create a variable for that. Head over to the editor and add a sphere to the scene. In the same way as for the plane, you can use the create button in the hierarchy or the game object menu for that. Rename it to bullet. We want our bullet to be a projectile with mass and physics behavior. We can achieve this by adding a rigid body component to it. We also need this component to be able to apply force to our bullet when shooting it away from the player. Select your bullet in the hierarchy and press the Add Component button in the inspector. We can find the rigid body component in the physics subfolder or by typing rigid body in the search field. Later, of course, we don't want only one bullet sitting somewhere in our scene, but instead repeatedly shoot bullets from our player's position. The concept of prefabs enables us to do that. But first we should make our bullet a little smaller. Make sure to select the bullet in the hierarchy and adjust the X, Y and Z scale to 0.3 in the inspector. To transform our bullet into a prefab, simply drag it from the hierarchy into your Assets folder in the Project tab. We can now delete the original bullet from our scene. Also, we should clean up our Assets folder and create a prefab subfolder. We will put all prefabs that we create along the way in there. Now drag the newly created prefab into the empty slot in our Aim and Shoot script. Let's get back to the script and do some coding. We would like to shoot one of our bullets whenever we do a left click with our mouse. We need to check if the left mouse button is pressed in each update frame. To do so, type if input.getButtonDown fire 1. Inside the if condition we want to instantiate one of our bullets. Let's have a look at Unity's documentation page about instantiating objects. We are offered two different versions of the instantiate function. We will use the first one as we can also pass a position at which our object is instantiated. If we were to use the second version, our instantiated objects would be created at the origin of our coordinate system. Let's get back to our script and instantiate one of our bullets. We need to buffer our instantiated object as we want to apply force to it afterwards. So create a new game object variable named current and assign the result of the instantiate function to it. Remember, the first parameter of the instantiate function expects the original object we wish to clone. Therefore we feed it our bullet. The second parameter would be the position the bullet is instantiated at. We want the bullet to emerge from the player's position. We can use our center eye anchor for that, which we saved in a variable named direction. Access its position by direction.position. Finally, we need to feed a rotation to the function. It doesn't really matter as our bullet is round. Rotations in Unity are of type quaternion. We can use the static variable quaternion.identity, which effectively sets our bullet's rotation to no rotation whatsoever. As a last step, we need to cast our instantiated object into a game object. We can do that by typing as game object after the instantiate function call, or by typing game object in parentheses in front of the function call. Now that we have created our bullet, let's shoot it away from the player. First, we will need to access the rigid body component of our current bullet. We can do that by typing current.getComponentRigidBody. In brief, we call the getComponent function on our current bullet. This is why we need normal parentheses in the end to denote the function call. Potentially, a function call can require you to feed in parameters, as we did with the instantiate function before. Even though the getComponent function doesn't need any parameters, the parentheses remain, which also allows us to recognize it as a function. The getComponent function, however, is a generic function. This is why we need to denote a generic type, meaning the component we wish to retrieve from the game object in angle brackets. I linked you to Unity's documentation page and tutorial video about generic functions if you wish to know more about this topic. Now that we have access to the rigid body component of our current bullet, we can add a physics force to it in order to fling it away from the player. We can use the public function named addForce of the rigid body component. We need to feed it a direction vector in which we want to apply the force. This vector is contained in our direction variable and can be accessed via direction.forward. In fact, the standard force applied to the bullet will not suffice to make it fly away into the distance. Right now it would rather drop to the floor right in front of us. We therefore need to multiply the force vector with some intensity. The best way to do that is to introduce a public float variable for our intensity at the top of our script. We can then multiply our force vector with this variable. As we made it public, we have access from within the editor, also while playtesting our game. Actually, we could do that now. Go back to the editor and select the player controller. Enter 500 as intensity in the aim and shoot script. You can adjust the intensity to your needs, depending on how far you want to shoot bullets away. Now test your game and shoot some bullets by clicking left with your mouse. Notice how the bullets are instantiated very close to the player's camera. Let's introduce an offset in the script. Simply add direction.forward multiplied by our offset where the position of the instantiated object is calculated. Set the value of the offset to 1 in the editor and test your game again. Now the bullets are instantiated a bit in front of the player, which simply makes it look a bit better. At this point you could potentially build your game into an executable. If however you wish to shoot your bullets from a gun instead from the player's head, you can add a transform to the gun's front as a child and change the position at which the bullet is instantiated in our script. I will show you quickly how that can be done. Create a cube and rename it to gun. Now adjust its scale in the transform component so that it looks gun-shaped. Later in your game you would of course use an appropriate 3D model instead. Drag your gun onto the center eye anchor. This effectively makes it a child of the center eye anchor and therefore follow its position and rotation. Now detach the game window from the editor and put it next to the scene view. First reset the position of your gun, then adjust its position until you can see it properly in the game view. Now create an empty game object from the game object menu. It only contains a transform component. Rename it to gun front and make it a child of our gun by dragging and dropping it onto our gun in the hierarchy. Reset its position as well as its rotation and move it in the scene view until its position matches the front of the gun. Make sure to place it a little bit in front of your gun, as a bullet might get deflected if your gun front sits in the gun model. Now go back to the aim and shoot script and introduce a public variable of type transform to store our gun front. Name it gun front respectively. Replace the position at which the bullet is instantiated by gunfront.position and the direction vector in which the force is applied by gunfront.forward. Go back to the editor and assign your gunfront game object to the empty slot for the gunfront in the aim and shoot script. Detach your game window again and put it back into its original position in order to make the game view bigger for testing. Test your game to make sure that the bullets are emerging from the front of your gun and get thrown in the distance properly. Now you can build your game for a full screen test.